Good day, Earth Science students. Welcome to Video Lecture, Episode 25. Today we're going to continue our discussion of the inner planets. Remember last time when we finished up, we were talking about Venera 7, sent by the former Soviet Union, was sent to try to photograph from her Venus, but it stopped about less than an hour due to the high temperature and pressure of the planet Venus. Well, between 1990 and 1994, the United States sent the U.S. Magellan probe, and they used its radar to make the most detailed maps yet of Venus' surface. In fact, they collected from it, the radar images, 98% of Venus' surface, which is pretty amazing. Now, what I'd like you to notice is look on slide 53 and you can see some images. You can notice the huge volcano with visible lava flows that's seen on that image there. There's also clouds on Venus that are so dense that only a small percentage of sunlight that strikes the top of the clouds actually reaches the planet's surface. Much of the solar energy that does reach the surface is trapped by carbon dioxide gas in Venus's atmosphere, and this causes a greenhouse effect similar to, but more intense than the one that Earth has. Alright? Now, due to this intense greenhouse effect, temperatures on the surface of Venus are between 450 degrees Celsius and 475 degrees Celsius. That is hot. Alright, let's move to the next inner planet, and the planet we're most familiar with, and that's the planet Earth. Of course, this is the third planet from the Sun. That's why it also gets a nickname, third rock from the Sun. The average distance from Earth to the Sun is 150 million kilometers, or 1 astronomical unit, which is abbreviated by AU. Unlike other planets, surface temperatures on Earth allow water to exist as a solid, liquid, and a gas. Earth's atmosphere causes most meteors to burn up before they reach the surface, and it protects life forms from the effects of the sun's intense radiation. Alright, now let's move to the next planet, and this one is Mars. Can you guess why Mars, the fourth planet from the Sun, has been called the Red Planet? Look at slide 58. I think that'll give some clues. Hopefully it should. Well, let's talk a little bit more about it. Iron oxide in the weathered rocks on its surface gives it a reddish-yellow color. Other features of Mars, visible from Earth, are its polar ice caps and changes in the coloring of the planet's surface. Now you can see that on both slides 58 and 59. Alright? Now the ice caps are made mostly of frozen carbon dioxide and frozen water. Most of the information scientists have about Mars came from Mariner 9, the Viking probes, Mars Global Surveyor, and Mars Pathfinder. These are just a few things we've used to explore and been able to get data and pictures from this planet. Now, Mariner 9 orbited Mars in 1971 and 1972. It revealed long channels on the planet that might have been carved by flowing water. Mariner 9 also discovered the largest volcano in the solar system, that being Olympus Mons, and you can see this on slide 61. I have some images there. Olympus Mons is probably extinct. Large rift valleys that formed in the Martian crust also were discovered. One such valley, the Valley Marinerinus, which is shown on slide 62, you can see that as well. Well, let's talk a little bit about the Viking probes. The Viking 1 and 2 probes arrived at Mars in 1976. Each spacecraft consisted of an orbiter and a lander, and you can see the visual images of that on slide 63. The Viking 1 and 2 orbiters photographed the entire surface of Mars from their orbits, while the Viking 1 and 2 landers touched down on the planet's surface. The landers carried equipment to detect possible life on Mars. Some of this equipment was designed to analyze gases given off by Martian soil. These experiments found no conclusive evidence of gaseous life byproducts coming from the soil. The Viking landers also sent back pictures of a reddish-colored, wind-swept surface, and you can see that on slides 65 and 66. I have a graphic representation of that. The Mars Pathfinder. So let's move and talk a little bit about the Global Surveyor and Pathfinder. The Mars Pathfinder carried a robot rover named Sojourner, with equipment that allowed it to analyze samples of Martian rock and soil. Data from these tests indicated that iron in Mars crust might have been leached out by groundwater. Mars Pathfinder also gathered data on Mars weather. Okay. In addition, cameras on board Global Surveyor showed features that looked like gullies formed by flowing water and deposits of soil and rock carried by water flows. And you can see a picture of what that particular device looks like that got this information on slide 68. Now, the features, which if you look on slide 69, are young enough that scientists are considering the idea that liquid groundwater may exist actually on Mars, and that it sometimes reaches the surface, which is kind of interesting to think about. Now, it is also possible that recent volcanic activity could have melted frost beneath the Martian surface. That's something that's also a consideration by scientists. The features compare to those left by flash floods on Earth, such as Mount St. Helens. If you're not familiar with Mount St. Helens, I do have on slide 70 a picture of what that looks like, so at least you can have a visual graphic to go along with that thought. Now, scientists also believe that water is frozen into Mars' crust at the poles, and if you look at slides 71 and 72, I have an image that I believe is a computer model of the data we have. The Viking and Global Surveyor probes analyze gases in the Martian atmosphere and determine atmospheric pressure and temperature. Pretty cool to think about. They found that Mars' atmosphere is much thinner than Earth's. It is composed mostly of carbon dioxide with some nitrogen and argon. I do have on slide 73 a representation of those elements, that being nitrogen and argon. All right. Now, just let's consider some more, as we've been already kind of just touching into Mars' atmosphere, and that is surface temperatures range from negative 125 degrees Celsius to 35 degrees Celsius, so it's quite a range there. The temperature difference between day and night results in strong winds on the planet, which can cause global dust storms during certain seasons. Well, this information will help in planning possible human exploration of Mars in the future. Keep in mind, if we ever do visit the planet, we do need to know about weather conditions and other things that could be a hindrance or could be something that would make us adjust when we do our surveys after landing on the planet's surface. Let's talk about Martian seasons. Mars is tilted on its axis 25 degrees, which is close to Earth's tilt of 23.5 degrees. Because of this, Mars goes through seasons as it orbits the Sun, just like Earth does, which is kind of interesting to think about. The polar ice caps get larger during the Martian winter as ice collects on their surface. The ice caps shrink during the summer. As one cap shrinks, the other expands, and both their surfaces change color during different seasons. Pretty cool that we've been able to actually observe this stuff and get that data via these multiple probes we send out. Now, wind causes the seasonal changes in the coloration of the Martian surface. When the seasons change, wind blows the dust around on the planet's surface. As dust blows off one area, it might look darker. I have some images on slide 78 to represent that, to give you a kind of a visualization. Well, now let's talk about the Martian moons. Okay, Mars has two small, irregularly shaped moons that are heavily cratered. Phobos, which I actually do have a picture of on slide 79, is about 25 kilometers in length, and Deimos is about 13 kilometers in length, and I believe that's on slide 79. There's a picture of that one as well. Deimos orbits Mars once every 31 hours, while Phobos speeds around Mars once every 7 hours. Phobos has grooves on its surface that seem to radiate out in all directions from the giant Stickney crater. Okay. Some of the grooves are 700 meters across and 90 meters deep. That's pretty crazy when you think about those numbers. Phobos' orbit is spiraling slowly inward towards Mars, which could indicate... Well, what could that indicate? Well, it's expected to crash into the Martian surface in the years to come. In other words, Phobos is looking like it's going to at some point crash into Mars and no longer be a moon, but then be part of a crater impact. Deimos is the outer of Mars' two moons. It is among the smallest known moons in the solar system in which we are a part of. Now, its surface, that referring to Deimos, is smoother in appearance than that of Phobos because some of its craters have partially filled with soil and rock. As you toured the inner planets through the eyes of the space probes, you saw how each of these planets is unique. We looked at Mercury, Venus, Earth, and now Mars. All right. Now, Table 3 was in your textbook, kind of gave a summary of the planets. I can post something similar to that, but really a good summary would just be reviewing the videos that we've gone over. I think we've covered pretty sufficient information, and if you are curious about more, feel free to reach out to me. You can leave comments below, and this is going to end our lecture here today. Have a nice day, and take care, students.